I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we have taken many questions based on integration. I have classified them in different categories. We'll discuss trigonometric functions with their substitutions in first part of this playlist. In this video, we'll discuss how do we integrate cos to the power of 5x sine square x dx. We'll understand this strategy. So here is the question for you. We are trying to understand how do we substitute when we need to find the integral of cos to the power of mx sine to the power of nx dx, means product, right? Now, the strategy is mainly based on what type of exponent is there. So I have summarized the name of the strategy is keep odd aside. So keep odd aside really helps you to understand what should we do. And what is the idea behind it? Let me just share that with you. Since these concepts help us further on, how do we solve more complicated questions? So in this particular case, we see that the degree of cos is 4 and that of sine is 3. So odd degree is that of sine, right? Keep it aside means I will rewrite this as equal to integral of cos to the power of 4x times, take the even degree part of it, which is sine square x, and then sine x dx. Do you see that? So what I did was that I split sine cube x into two components, the even and the odd. Now, when we are going to substitute, we'll see that this part becomes du, right? So one thing is very clear. We are going to clearly write u as equal to cos x, correct? So if I write u as cos x, then du will be equal to minus sine x dx, right? So as you can see, the function cos 4x can be written as u to the power of 4. What are you going to do with sine square x? Well, you know the identity which is between the even powers, that is cos square x plus sine square x is equal to 1. And therefore, I could write sine square x as equal to 1 minus cos square x. You understand? So I get all the components in terms of cosine itself. Do you see the beauty? So we'll rewrite this integral as cos to the power of 4x and sine square x as 1 minus cos square x. And then we have sine x dx. You see that? So now this substitution, which I was talking about, is u equals to cos x makes a lot of sense because then du is minus sine x. Perfect. So we would rewrite the integral in terms of u now. So we have integral of u to the power of 4, right? 1 minus u squared, and sine x dx can be written as minus du, right? So I'll write du here and a negative sign outside. Does it make sense to you? Clear? Now that is a very simple integral to find the answer, right? So we'll find the solution on the next page. So what did we do here? So basically, we wrote this integral as cos to the power of 4x times 1 minus cos square x, right? This is for sine square x, and sine x dx. And we made a substitution u equals to cos x. That means du will be minus sine x dx, right? And therefore, we could now write this as minus integral of u to the power of 4, 1 minus u square, and that is du. Makes sense? Perfect. So, this strategy, keep odd aside, really works very well. Perfect. Now, we can easily expand this and find the integral, right? So, let's figure this out. So, we have u to the power of 4 minus u to the power of 6, right? Du, and that gives you minus u to the power of 4 means u to the power of 5 over 5, correct? Let me write square brackets outside, minus u to the power of 7 over 7, and of course plus c, and now we can open the bracket, minus u is cos x, so it is cos to the power of 5x over 5, change the signs, plus cos to the power of 7x over 7 plus c. Makes sense? That is how we are going to solve this particular question, right? So you see how easily we answered this particular problem. So here we had cos to the power of 5x sine square x. Now, I'd like you to do the next question yourself, where we have even power for cosine and the odd power of sine. How are you going to solve this one? Well, let's look into this also, right? Well, in case you want to learn from me directly, feel free to send an email on globalmathinstitute at gmail.com. You can also support our channel by contributing. Every dollar counts. As you know, we have been serving you for the last 15 years absolutely free with 17,000 plus videos, right? Your support can help millions worldwide to get quality education. Now, let's look into the second example. Now, in this case, we have taken a variation, right? So here, the cosine power is odd. So what am I going to do? I'm going to rewrite this as integral of cos to the power of 4x times sine square x, the fifth power. Now I will write as cos x dx. And clearly, my substitution should be what? U will be sine x, right? So du will be cos x dx. Makes sense. So this cos x dx is now du for me. So I could rewrite this as integral of, now cos to the power of 4 is cos square x whole square, right? And we have put u as sine x, right? So cos to the power of 4, I will write this as 1 minus sine square x whole square, right? So that is cos to the power of 4 and times sine square x. Makes sense, right? Times cos x dx. Still, I haven't done the substitution yet, right? So I hope it's making sense. So what I did was that I wrote cos to the power of 4x as equal to cos square x whole square, which is indeed 1 minus sine square x whole square, right? So that is what I've done here. So let me now substitute, right? So we have 1 minus sine square x. I'm substituting u for sine x, right? So I get 1 minus u square whole square times u square times cos x dx is what? Cos x dx is basically equals to du, right? So I'll substitute du for that. So that is a neat substitution. Let us now expand this, right? So we have 1 minus 2ab, which is 2u square, plus u to the power of 4 times u square du, correct? Now we can open this bracket and rewrite our expression. So I'll take it on the next page, right? So, well, on the next page, we'll take this integral as equal to integral of, let me just copy it from here, 1 minus u square whole square times u square, right? So which is 1 minus 2u square plus u to the power of 4 times u square du. Makes sense, correct? So that is what we have. And we did a substitution where u was the even power of sine, right? So that is what it was. So if you open this bracket, what do you get? You get integral of u square minus 2u to the power of 4 plus u to the power of 6 du. And the integral will be, apply the power rule, u cube over 3 minus 2 times u to the power of 5 over 5 plus u to the power of 7 over 7 plus c, right? Substituting back sine x for u, we get sine cube x over 3 minus 2 over 5 sine to the power of 5x plus sine to the power of 7x over 7 plus c, correct? So that becomes our solution for this particular equation. So you see how this strategy to keep odd aside really works, right? Now what happens when we take both as odd, right? So here is another example where cos to the power of 5x and sine to the power of 3x dx is to be considered. Now in this particular case, what are we going to do? Because both are odd, we could actually take any one of them as u, right? Okay, so in this case, how do we work? So now let us take u as equal to cos to the power cos x. In that case, du will be equals to minus sine x dx, correct? And so we have taken care of one of them. Now we'll rewrite this as sine square x. We can write cos to the power of 5x sine square x, correct? Times sine x dx. Makes sense, right? Similar strategy. Now, sine square x is 1 minus cos square x. Let me rewrite here itself, right? So, cos to the power of 5x times 1 minus cos square x times sine x dx. So, if both are odd, take any one of them outside. That's okay. Now we'll substitute u for cos x and we get integral of u to the power of 5 times 1 minus u square, and sine x dx is minus du, right? So I'm writing minus here and du. Open the bracket, we get u to the power of 5 minus u to the power of 7, right? Du. And now we can integrate using the power rule. So we get u to the power of 6 over 6 plus u to the power of 8 over 8 plus c, right? And that gives us minus u is cos, right? So get cos of 6x power, right, over 6 plus cos to the power of 9x over 8, sorry, 8x, not 9, 8, right? 8x over 8 plus c. So that becomes the solution of this particular problem. So see how we have solved all these questions without any problem, correct? So that is how we should be doing it. Perfect. So I hope the concept is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. So we solved actually 3 of these questions in this particular video. Perfect. Follow our playlist to learn more. Solutions of all these questions will be provided in our playlist. Thanks for your time and all the best.